Unit 2 here. Unit 2 is all about congruent triangles, and then in the later lessons it was congruent parallelograms. So there are certain things we have to know about the triangles for them to know that they are congruent, and we can take some shortcuts there. So first thing is, what does it mean for two figures to be congruent? Well, they have the same size and shape, and also there is a rigid transformation that takes one to the other, or a rigid motion. What are the rigid motions? Well, we have a translation, rotation, and a reflection. There is nothing about dilations. Dilation actually does the exact opposite of a rigid transformation. Dilation changes the size. All right, congruent figures. They can be carried on one to the other using those, no resizing, and they preserve distance, which would be the sides of our shape, and angle measures. So if one figure can be rotated and translated to figure 2, figure 1 can be rotated and translated to figure 2, are they congruent? Yes, because those two things, rotated and translation, is a rigid motion. If one figure needs a dilation to match another, are they congruent? No. You need to know these theorems: side, 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 angle, side, angle, side, angle, 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 side, and know that side, side, angle is not valid. I know that we talked about HL, hypotenuse leg, but that is actually not going to be on the test. Why would side, side, angle not be a valid congruence theorem? Because it can produce more than one triangle. If you remember the video I showed, it could produce two different triangles. Sometimes you can give a side-side angle, and depending on where you put the angle, it could produce not a triangle. It could not have enough length on one of the sides to produce a triangle. So which theorem can prove congruence if we given two sides and the angle included? So that would be side, angle, side. Don't worry about that. All right, these are the things you need to know about parallelograms. And let's go ahead and add this. Consecutive angles are supplementary. That means they add to be 180. So let's do a little problem here. So if I have parallelogram A, B, C, and D, and these are the links here, let's go ahead and see if we can figure out and fill in all the other links and angles. So if opposite sides are congruent, then the opposite side of AD is BC, and that would be 10. The opposite side of DC is AB, and that is 12. Then my opposite angles are congruent, so the opposite angle of D is B, and that would be 85 degrees. And then A and B are supplementary. So if I take 85 from 180, that leaves 95. So A is 95, and then opposite of A is C. Make sure you know what angle is being named. So if it says angle ABC, B is our vertex. That is the angle at the point where the two sides meet. So A, B, C, we're talking about this angle. Okay, let's go ahead and talk about our diagonals bisecting each other. So if I have a parallelogram, because I say it's a parallelogram no matter what kind it is, a rhombus, a square, a rectangle, just a general parallelogram, and we're talking about our diagonals, that means they bisect each other. Okay, that means this one is cut in half and this one is cut in half. If this is a rectangle, then AC and DB are congruent to each other, so they will all be the same. But if I'm looking at DB, I know that DE is half, sorry, this should not be congruent, should be equal, half of DB. So this is half of this whole side. So if I said DE equals 5, then what does DB equal? So we're going to multiply 5 times 2, and you get 10. If I said DB equaled 12, what does DE equal? Then I'm going to take 12 and divide it by 2, and I get 6. All right, which of these are true for all parallelograms? Well, opposite sides are congruent, diagonals bisect each other, opposite angles are congruent. For right angles, no, that's only for rectangles. Diagonals intersect at right angles, no, that is only for rhombuses. But you may need those, so you may want to remember those. All right. Definitions to know: rigid motion, transformation that preserves distance and angles. These are just, we'll keep going over these, so that's how important for you to remember them. Congruence, it's a relationship between figures that can be mapped into each other by rigid motions, which transformations preserve size and shape. We've said it before: rotation, reflection, translation. So different quadrilaterals, which it doesn't have to be a parallelogram. Quadrilaterals just has 4 sides. We have been talking about parallelograms though. So our first type of quadrilateral is a parallelogram. Opposite sides are parallel, that's what that means, and congruent. Diagonals bisect each other. So if it was a rectangle, it has 4 right angles. Rectangles are congruent. For a rhombus, 4 congruent sides. Diagonals are perpendicular, and they bisect each other. So it means, hey, it's perpendicular there and there. Doesn't mean they have to be the same. Rectangle, these have to be the same. All right, and a square has all of these, because remember, if a rectangle and a rhombus had a baby, it would be a square. All similar triangles are congruent, true or false? Similar does not mean congruent. Similar is actually something we'll be doing in Unit 3, and it just means they're proportional. So, no. Similar triangles does not mean that they are congruent. Which theorem can prove congruence of 2 sides and the included angle? And we already did this one. It's just repeating itself, side angle side. If both pairs of opposite sides in a quadrilateral are parallel, what shape is it? If opposite sides are parallel, it is a parallelogram. So you really only need one of these things to know that it is a parallelogram. If I say opposite sides are congruent, you know that it's a parallelogram. If I said opposite angles are congruent, parallelogram. Same with the other two. If 2 triangles are congruent, what can you say about the corresponding parts? They are congruent. CPCTC. Corresponding parts of congruent triangles are congruent. And the exit ticket is something we've been doing already. Side, side, side. Angle, side, angle, side, angle, side, angle, angle, side. So we know all these. You don't worry about answering those. You can go back and look at those. Let's look at a couple of things that you need to remember. Let's remember that if I have congruent triangles, they have to be marked the same. So if I say that I'm going to mark them side, angle, side, or if I want to prove them congruent by side, angle, side, that one's marked side, angle, side. But this one is not. That one's actually side, side, angle. Okay? And this one also would not be. So don't look at two of these, those two, and say, oh, they're right. They both have two sides and an angle. They're congruent to each other. No, because this one is not marked side, angle, side. So make sure that they are marked the same. Remember, vertical angles are congruent. So sometimes you may have something that looks like this, and it's talking about like prove these two triangles are congruent, and it may not have an angle marked. It may have something like this, and you don't have any angles, so you're like, oh, I can't prove that. Well, these angles are congruent because they are vertical angles. Make sure you don't have any dilations. If it mentions dilations, it is not congruent triangles. And one more thing, well, actually, two more things. Let's look at this. If we have a parallelogram and we know it's parallel because either they tell us it's parallel or it's marked with these, okay, and then it gives us a diagonal. We know that if we're using this top and bottom side, that this angle and this angle are congruent. And then this angle and this angle are congruent. All right, remember that we can rotate that top triangle, that top triangle down, and this angle ends up right here. So know that. Also a congruent statement, if I have triangle ABC is congruent to triangle EFG, then A goes with E, B goes with F, C goes with G. So if I said side AC is congruent to what? Well, AC would have to be congruent with EG. And if I move the letters around and say BAC, I'd have to go B goes with F, A goes with E, C goes with G. So make sure you know all about that congruent statement. All right, study up, do your best.